In this video, we're looking at the end-to-end process in terms of submitting a workload to YellowDog for execution and the provisioning of compute. So what you're looking at right now is the compute requirement, which I've submitted through our Python client. We also have Java and .NET clients. But this one is to create a mini cluster in OCI across 5 different machine shapes. I have Frankfurt VM standard 2.4s, London VM standard 2.4s, and Ashburn VM standard 2.4s. I'm currently getting the resources I need between London and Frankfurt. I've asked for 5 instances, and you can see there's just one instance just waiting to come in now from Frankfurt. It's currently in a pending state. This particular compute requirement was created using a template, and the template was this one that you can see up here. So let's have a look and see what's in that. Okay, so the template here is what we call a static template. So I'm already defining the instances and the types that I'd like to get. You can see here we have it's a split provision, which means that the compute requirement will try and go out and split the instance types between them as much as it can. So right now we have Frankfurt, as I was saying, London and Ashburn. We have also decided the instance type here, as you can see. The key thing is the images ID. So the images ID is particularly important because in this case I've specified a path to an image ID on our YellowDog image registry. So let's have a look at that image path. So that image path is listed here. I've got an image family called YD Agent Docker. And as you can see, there are quite a few images stored under version 1.12. And the key thing with using the image registry is I don't have to provide the individual image IDs when I'm provisioning. I can just provide the path and let the YellowDog compute service look up at the correct image that's required to provision my instance. So you can see here I've already listed the OSID for the Oracle machine in Frankfurt, and also if you look here we can see the London one and the Ashburn one. So the key thing with using the image registry is you can specify the path rather than having to know the individual image IDs that are required for each individual instance that you want to provision. Okay, let's go look at the workload now. As you can see, the workload is currently working. It's made up of 2 task groups, image processors and image montage, and the montage task group is dependent on the completion of the image processors task group. The key thing I want to look at first really is the run specification. So that tells us what attributes have been given to the the work requirement in order to complete the particular tasks that are in it. So we can see here that the queue concurrency, the minimum and the ideal are set to 5. This means that this task requires a minimum of 5 workers to complete, and ideally that should be maintained as 5 all throughout the processing. There are worker claim and release strategies listed here. The key one is right at the end, when this is all completed running, we will release all these workers and actually bring down the compute automatically. We can decide to share workers, how many maximum task retries there are, if there's any issues with the tasks processing, and the worker tag. So I'm picking up workers which have this particular tag here listed on them. If we open up the actual tasks themselves, we'll see things like init data in order to run the task. We have also got inputs and outputs in terms of objects that need to be there before processing and the objects that need to be collected once processing is actually done. And we do that using our object store service, which allows us to access the object store services of the cloud providers that we support. So let's have a look at that right now. So if we go to objects, I'm running this under namespace image demo, and as you can see, we're starting to build up the a list of the actual outputs from each of the individual tasks that were run, and that could be the output from a specific task, or it could also be task outputs. In other words, giving you some logging as to what has happened as the task has progressed. Just while we're waiting for that workload to complete, we only have 1 task left, which should be the image montage, which will be done once the image processor tasks have complete. I want to look at some other things you can look at while compute requirements and work requirements are actually active and doing work. Logging in particular is always a good one to look at. We can set the log level to include everything, and we can look at live logs, and this will show what the individual YellowDog services have been doing while we've been running both the compute requirements and the work requirement. And as you can see here, you can see even get logging back from the worker. So we can see this is executing a Docker command. We see the task is now complete. And we see some of the workers already uploading their objects, once they were completed the task that was assigned to him. We can also look at usage. So usage will give us the what's actually been used while these tasks have been executed. We can look at usage by different users or applications. We can look across different time frames. And what I'm interested in here is looking at the usage for my currently running tasks. So I can filter down by namespace, which is analogous to a project, and then look at the current compute requirement that's running. As you can see here, this is the one with the worker pool designation on it. And I can select that, and we'll see then the individual instances that are running, the instance type and the source. The number of instances, and of course, if you recall, it was 2 and 3, 2 from Frankfurt, 3 from London to make up a 5, and that's the total time spent in each of those individual instances. If we go back now to the workload, we'll see the workload is now marked as completed. All tasks are done. And what will happen, as we've said in the task group, in the work requirement run specification, that we will release all workers once all tasks are complete. And if we go back to the compute, we shall shortly see a terminated request or terminating request come through from the work requirement to say no more tasks are coming through from me, so therefore we should now bring down compute, and you'll shortly see that coming through. So that was a very, very quick run through of what's happened end to end with the running a work requirement and provisioning via YellowDog. So you saw the compute requirement, which we're looking at right now. We also saw running the compute requirement using a path to images. We also looked at the work requirement itself, the various task dependencies, whether they be based on other tasks in the group or objects. We looked at other items that you can see while the work requirement and compute requirements are processing, which are things like logs and usage. That's what I have for today. Thank you very much for watching.